各位来宾，上午好，欢迎出席第10届网络社会年会。首先有请发言嘉宾詹姆斯·斯坦霍夫老师，他是都柏林大学助理教授，深耕于人工智能与数字媒体的政治经济学领域。他的演讲主题是“提示工程与非决定论的政治经济学”。有请。
It's a real pleasure. So, first of all, my background is from media theory, media studies, but specifically political economy of media. So this talk's going to do a little bit of media theory, a little bit of political economy, early in the morning. So I hope that's exciting. Yeah, so this is not going to be a talk about an existing paper or research that I have worked on. This is a talk that I created in response to the prompt that was given to me. So like a good LLM, I have generated this prompt about prompting. So I think it's a very timely moment to talk about the political economy of AI. Despite impressive advances in the technology and unprecedented amounts of funding being devoted to AI research around the world, AI doesn't seem to be doing what capital wants it to do. At least it's not generating surplus value. A recent study this year done by MIT researchers shows that in analysis of 300 firms I think in the US, but maybe globally. But in any case, 95% of these companies that have spent money on incorporating generative AI are showing zero return on investment. So that's only 5% getting any kind of return on investment from Gen AI. And other research at the individual level or like team level of labor productivity shows that while individual workers can increase their productivity by some metrics, this tends to decrease quality of output in coding and other kinds of work. So this raises the question of the AI bubble. And I'd be interested in hearing whether that discussion is being had in China or not. I don't know. But certainly in the West, in the last few months, the AI bubble has gone from a topic for some fringe or more niche commentators to being discussed in mainstream business journalism. So the question is, whether the expectations and investment around AI have outpaced technical capacities and viable applications. And to some degree, this seems evidently true. Now the AI industry is trying to push AI agents as the new thing. It's not clear to me whether an AI agent is different than a large language model with a longer memory, but that remains to be seen. So I want to consider whether the looming specter of an AI bubble might have something to do with prompting, this distinctive way that we interface with the most popular AI applications today. But first, I want to do a bit of conceptual or theory talking, considering AI, capital, and automation. So automation is the primary lens through which I think about capital. Marx's analysis of capital describes capital as a sort of undead parasite which feeds off the output of human beings. And this output eventually takes the form of machines, And these machines, Marx has insisted, consist of this sort of captured knowledge and skills of living labor that have been, quote, absorbed into capital, as he puts it in the Grundrisse. And this concept of absorption is really essential to me lately, and I think essential to thinking about AI and automation. So a fair response at this point might be, why automation? And it's true that capital's prime directive is valorization, right? The generation of surplus value. But absorption and automation are also important goals for capital, insofar as absorption is the means of achieving valorization, or at least increasing the productivity of labor. And just as new means of production must be developed because of competition, so do new means of absorption. And the qualitative logic of absorption, and thus automation, can change over time, just as the means of production might change qualitatively over time. Uh-oh. Ah, okay. So I've been trying to think about this idea of how absorption might qualitatively change over time, and I've done so in a recent paper last year. The broad strokes are that historically the logic of absorption has been one of capture, but I argue that there are signs of a shift to a different paradigm, which I've called emergence, and that's driven by machine learning. I'll say a bit more about that in a minute. But first, a bit about the AI industry as an industry. In my view, the AI industry is the industry of automating automation. So the automation of automation, or meta-automation. It produces machine learning models, and machine learning models automate automation by extracting patterns from data. Machine learning allows one to produce an algorithm which may direct a machine to perform a task automatically. But to see it as a form of automating automation, it's necessary to take a historical perspective. We need to think back to the first commercial era of AI, beginning in the 1980s, which was not based on machine learning, but on the symbolic AI paradigm. And absorption in that context involved a completely different labor process to for the production of AI systems. So there was a thing called knowledge engineering at that time of the early AI. And this was literally the extraction of expert knowledge from expert workers through interviews and different processes of observation. And then the knowledge engineers would encode that captured knowledge in a symbolic form, and it would be implemented in this rule-based expert system that could then be queried by less experienced workers or management about who lacked that knowledge or skills. So it was quite literally this capture of skills and transfer to a machine. So if we consider machine learning in relation to that, you can see that machine learning dispenses with that whole process of knowledge engineering and enables the production of algorithms on the basis of patterns that are in the data in a semi-automated manner. So that's what I'm talking about with the idea of emergence. And this process was and is still vaunted by its proponents as offering more objective access to scientific knowledge. But from the perspective of capital, it offers the possibility of automation without having to capture knowledge directly from living labor. Now, I want to emphasize that the story is not really that simple. The process of automating automation enabled by machine learning doesn't always, or perhaps ever, go completely smoothly or completely automatically. All kinds of labor is still required. But I still think a qualitative change is visible in a rudimentary form. at least. In any case, automation is driven by competition between individual capitals. Each firm has to match and ideally exceed the labor productivity of its competitors to remain capable of generating a surplus. So capital thus has an inherent temporal logic of acceleration as labor time is desired to be kept to a minimum. Automation is about speed in this sense. This is certainly true, but I would also suggest that there's a logic of contingency reduction in automation. Automation is not only about optimizing labor productivity as a quantitative metric, but it's also deployed to affect qualitative changes in the labor process in order to eliminate contingency. So automation is about speed, but it's also about control. Eliminating contingency is important because contingency represents all the possible ways that valorization might be slowed down, interrupted, delayed, or even stopped entirely. An automated process is likely faster and cheaper than a non-automated one, but perhaps more importantly, is machines don't rebel, or more mundanely, they don't go to the toilet, right? So labor process theory, descending from Harry Braverman's groundbreaking 1974 book, Labor and Monopoly Capital, has offered some of the best theorizations of how this all works, in my opinion. But my favorite concise formulation comes from Craig Lidler's 1982 book. I forget the name of it now, but he describes the, quote, indeterminacy of labor potential. In other words, the worker is a reservoir of labor power, but labor power is the capacity to labor, not labor itself. The amount and the quality of labor that is derived from a particular source of labor power depends on what the worker chooses to put forth or what they are compelled to put forth. So labor power is an eminent source of contingency. More broadly, for valorization to be a success, a spatio-temporal process which involves the coordination of heterogeneous elements and agents, including labor, but also machines, other forms of capital, must be completed. In the labor process, contingency minimization manifests as Taylorism, the array of techniques for analyzing, dissecting, and optimizing how work is performed, tending towards the de-skilling of labor and consequent devaluing of labor power. Taylorism, as Braverman pointed out, creates the conditions for automation. By chopping up complex labor processes into discrete tasks, it allows those tasks to be more readily handed over to machines. More broadly, there are diverse efforts at increasing predictability, such as demand forecasting, sentiment analysis, and all kinds of machine learning-driven predictive analytics. The whole logistics revolution in circulation is another prime example of this, allowing production processes to be distributed across the world in unprecedented complexity. So capital's loathing, I would call it, of contingency means that it treats the world and even ontological fundamentals such as space and time as barriers, even as they provide the possibility of or the conditions of possibility for its existence in the first place. This language around barriers I find really interesting in Marx. So I'm going to look at a couple here. In the Grundrisse, Marx says that capital, by its nature, drives beyond every spatial barrier. He's thinking of the development of transport infrastructure in this context. But he also says that circulation time appears as a natural barrier to the realization of labor time. And it's not just space and time. Human beings are also considered barriers to capital. One of my favorite quotes is from Volume 1 of Capital, where he says that capital is animated by a drive to reduce to a minimum the resistance offered by man, that obstinate yet elastic natural barrier. So I think we can consider these barriers as a bunch of contingencies. And capital is thus always projecting itself into an ideal future where it has eliminated these barriers, where it's reduced these contingencies, managed them down to whatever level of acceptable predictability or whatever you want to call it, it can manage. So critics of Marxism like to call it a technologically determinist framework, but I think we can mischievously assert that Marxism actually reveals that capital produces determinism, or it wants to produce determinism, or it tries to. Of course, at the same time, it undermines determinism via the anarchy of market competition and the squandering of key resources, among other factors. So like most tendencies within capital, such as the tendency of the falling profit rate, the tendency to produce determinism might be called dialectical insofar as it involves the production of its own counter-tendencies. Okay, enough of the political economy. Where does prompting fit into all of this, you're probably asking? So, prompting, what is it? This is what I wanted to really delve into, and I'm doing for the first time as I was writing this, or researching this. So prompting, has been said yesterday, is a particular user interface, right, to a machine learning model. And we should place it in the class of technical objects such as a keyboard, a mouse, graphic user interface, a GUI. More precisely, prompting is an algorithmic technique, as the media theorists Burkhardt and Reeder have recently put it. They describe it like this: a gesture that combines characteristics of natural language, computer code, and probabilistic query. They also point out that prompting might be considered a kind of labor, potentially, and a kind of programming, right? Insofar as large language models don't have a specific task programmed into their architecture, prompting is a form of adapting the generic model to a desired downstream task. And interestingly, while prompting is ostensibly a natural language interface, it appears that better performance can be achieved by somewhat unconventional or unnatural deployments of language. If you look up, how to do prompting well, it's often not normal sentences. So, according to some industry commentators, the prompt engineer is the career of the future, or a career of the future, right? Some kind of worker whose special skills revolve around understanding the idiosyncrasies of different models and getting them to do what we want them to do. Now, I'm dubious about the long-term career prospects of prompt engineers, but that's probably a different discussion. In any case, if prompting is labor, it's an interesting kind of labor because of how automated it is. From a Marxist perspective, the living labor of the prompt engineer is relatively minimal when compared to the accrued dead labor crystallized in an LLM, including the labor of the data scientists and the engineers who created it, as well as the content of all the data it was trained on, scientific papers, journalistic articles, so on, as well as the reams of the data work that go into preparing the data, making it legible to the machines, the cleaning, the labeling, and so on, which is now an industry in its own right, arguably. But prompting is also an operation performed by capital insofar as an LLM can be deployed as fixed capital in a production process, like any other machine. And if it's used in a production process, a large language model functions in terms of value, like any other piece of fixed capital, transferring the value bestowed on it in production, piecemeal over its useful lifespan. Of course, as software, large language models or models in general don't decay over time in the same way that conventional machines did in Marx's original theorization. But that's also another topic for another time. Software and value theory is we could do a full conference on that if you're interested. So prompting calls an automation system into action, although it's a peculiar kind of automation because, as I said, up until the invention of the computer, at least, a machine was built to automate precisely one task, typically, and this was determined by its physical form. Like a drill press drills, a loom weaves, but a computer can implement arbitrarily many different programs, the magic of software, right? And an LLM can generate arbitrarily many outputs in response to being prompted. And prompting also contributes to directly to the formation of new fixed capital, insofar as prompts are typically recorded by the company making the model and then used as further training data down the road. What else can we say about prompting from different angles? Well, strangely enough, I found out that a prompt can also be a commodity. Maybe people are aware of this, but prompts are sold on prompt marketplaces now. You can go and buy a prompt. This was news to me, but yeah, there's websites such as PromptBase or ChatSonic. You can look these up, and here you pay for a particular string of letters that will input to a certain model and have a certain desired output. It's very bizarre to me, and I don't understand how it actually works. I don't know who's buying these. I have to look into it. If anyone knows about that, would love to hear who's buying these. But in any case, it does throw into further question, I think, the long-term viability of the prompt engineer as a career choice. At least the prompt engineer will have to compete with the prompt merchants in any case. So let's now maybe shift to a media theory perspective and consider how prompting actually works. And one of the questions that I had going into this was, why is prompting probabilistic, as Burkhardt and Reeder point out in that definition? Why is it that if you insert the same prompt to a model 15 times or even 4 or 5, you won't get exactly the same output? Why is this? We typically think of digital media and computers as, pretty deterministic systems. They're algorithms, right? An algorithm is by definition a rigorously specified series of steps that a system goes through, right? So why is it that an LLM is not predictable or deterministic? Now, I'm not going to pretend to have a mastery of the technical details here because I am not a computer scientist, but I'm going to do my best to convey to you what I have learned. So, prompting is probabilistic. One reason is because of the nature of generative models as a kind of storage medium. Like all machine learning, generative models involve a kind of compression. Felix mentioned this yesterday, the dimensionality reduction, right? The idea, of course, is that the model is smaller than all of the input data, or what would be the point, right? Then you'd just be doing a search if it was the same data. So a model is a compression. It gets rid of the unimportant stuff. That's the idea. You can see it here, the bottleneck, right? The idea is that the data goes in to the model in the learning process in such a way that the relevant patterns are not destroyed, so that you can then get them out through prompting. So the bottleneck, or the sort of compressed step in the middle here, is called the latent space, as we've heard about. And I think this perspective of thinking about AI models as compression media isn't really appreciated enough. And in thinking about this, I've been starting to consider whether we need to place generative AI in the history of compression technologies. So Jonathan Stern is a media theorist who recently died but worked in Quebec, in Canada, Montreal. And he has a 2012 book about the MP3 file format. It's called MP3, The Meaning of a Format. And there he suggests that we need to develop a sort of alternative history of media, not in terms of a trajectory of increasing fidelity to the real, but of increasingly sophisticated techniques for compressing data. Now, I haven't thought through the implications of this, but I think I just wanted to raise it because I think there's something to be, it's a fruitful way of thinking about AI. More to come on that in a couple years. So here we can see a visualization of latent space, right? It's an n-dimensional virtual space. And it's called latent because each dimension in the space responds to a latent variable in the original data. And latent variables are these underlying characteristics that inform the way data is distributed, but are maybe not directly observable in the data originally. So you can think, perhaps, of latent variables as patterns that are not captured by existing categories in the input data. So one way of thinking about the probabilistic nature of LLMs is that the probabilistic nature depends on how far the model reaches out into the latent space when it's trying to find an answer. And this reaching is defined by a parameter called temperature, as Nick and I were discussing a bit yesterday. So the lower the temperature of a model is set, the less random its responses will be to a prompt. The lower the temperature, less unpredictable, right? So if you have a really high temperature, it will treat very likely outputs and very unlikely outputs as more similar, producing a more chaotic range of outputs. So, does that mean if you crank the temperature down to 0, can you make it perform in a non-probabilistic way? This is widely held to be true, but it's actually not. So there's actually a deeper level to where the probabilistic nature comes from. And I would like to point out that this is really, really beyond my comprehension at this level, okay? So the generally accepted theory for where the indeterminacy comes from is called the concurrency plus floating point hypothesis. And this derives very roughly from the parallel nature of computations that are done during inference, and the necessity of rounding floating point numbers to achieve these computations. Essentially, it means that within the model, certain calculations are done in a different sequence depending on an array of factors, and the way the numbers are rounded produces slightly different outcomes. In any case, the important point is that the non-deterministic nature of LLMs comes from this underlying infrastructure. But we can note that this probabilistic nature of these models, it is part of their appeal, right? It is kind of what makes them feel not machine-like. You don't get the same answer all the time. There's contexts, a spontaneity maybe kind of feels like you're talking to a person maybe sometimes. And it might be useful for certain things like brainstorming ideas, getting iterations. But is this an adequate situation to capital, which is heavily invested in AI? If, as I've suggested, capital seeks to annihilate contingency, or at least minimize it, and to produce determinism as much as it can, how is it that capital is investing heavily in a technology which seems to be inherently contingent in its functioning? Now, if you look at industry materials, commentators on LLMs, the non-determinism was just kind of an accepted fact. You just had to deal with it. But it's starting to become a problem, explicitly addressed as a problem in the last year or two, at least that I can see it. And sometimes this is addressed in scientific terms. One commentator has said the following, that reproducibility is the bedrock of scientific progress. However, it's remarkably difficult to get reproducible results out of a large language model, right? Reproducing experimental experiments is the basis of science, and so LLMs place a pretty big obstacle to doing science with them. But the problem can also be framed in business terms. So this is from a large language model business commentator blog. And he points out here a number of concerns from the business perspective with the non-deterministic nature of LLMs. Broken evaluations, failed debugging, compliance risk, wasted money, training instability. These are all pretty telling. The third one, the compliance risk, is perhaps offers the most concise formulation of the problem. You can't guarantee consistent AI behavior. This, as he indicates, impinges on regulatory compliance, benchmarking, debugging, so on and so forth. Across all of these reasons, we can see a shared problem, a lack of predictability. Overall, it's a troubling display of contingency, which means that businesses cannot guarantee the performance of these machines, which they are basing their business models on or trying to sell, either way. So, this American AI company called Thinking Machines has recently claimed to have solved this problem in a report which they explicitly called Defeating Non-Determinism in LLM Inference. This came out, just last month. And they go on to argue that you can, in fact, defeat this infrastructural, probabilistic nature. I'm not even going to try to explain what they did. I don't comprehend it. But the point is they claim to have fixed the problem. There's a way to do it. They used a relatively simple, custom-built large language model, and they were able to make it output a response in a deterministic manner with no variation at all. So you can do this, in theory. But what's interesting is that this came at a huge cost. It had a 62% longer inference time, 62% longer time to run, to generate the output. And of course, this means 62% more computational power and energy being spent. So presumably, this can be optimized in the future, but it suggests that there's going to be a novel dimension of economic calculation for AI businesses. And it suggests a dimension of an emerging political economy of prompting. So with all machine learning, it seems to be the case that performance scales so far with increasing compute and training data. The more computing power, the more robust the model. Maybe this won't go on forever, but it seems to be so far. So this means that AI production constantly confronts an economic calculation between the desired performance of a model and the cost of acquiring and preparing the relevant data, as well as training the model and running the inference. Non-determinism was accepted as a part of this, but now if the results presented by thinking machines are legitimate, it means that another axis would have to be added to this problem where deterministic precision will be weighted against contingency reduction costs in inference. So one could then wonder, could rendering large language models fully deterministic stop the AI bubble from popping? Maybe. But, ... Oh, try this one? Okay. Another recent article from OpenAI researchers, Kelly et al., suggests otherwise. Another aspect of contingency seems to lie outside the process of inference. Kelly et al. Are interested in hallucinations. Topic came up yesterday evening. You know, hallucinations being those incorrect answers which LLMs confidently output. And the important thing about hallucinations is that even if a model does not in fact know an answer, it will tend to guess, grasping a somewhat plausible point in latent space, even if it is told to answer only if it knows the answer definitely. So the authors recount an interesting example. Yeah, pictured here. A query about the lead author's PhD thesis. And they told it, you know, only tell us about this if you definitely have the information. They did this to 3 different LLMs, ChatGPT, DeepSeek, and Llama, and each produced an incorrect, hallucinated response. So the report authors go on to assert that, quote, even if training data were error-free, the objectives optimized during language model training would lead to errors, hallucinations, being generated. And this derives, they argue, from a social dimension of LLM production. More specifically, they say this derives from the nature of the tests which are used to measure or benchmark LLM performance. These exams tend to use binary metrics, so right or wrong, and thereby penalize uncertainty. This produces models for which which are optimized in the long run to guess and sometimes be right, rather than simply admitting uncertainty or ignorance when it comes to a particular prompt. They provide another example in which LLM was asked to just provide the lead author's birthday if it knew confidently what the birthday was. And it got it wrong multiple times. But it was confident that it had the answer, right? So if this analysis is correct, then it seems that the socio-technical practices around the production of generative AI are teaching those models to dissimulate in an attempt to hide the contingency or non-determinism inherent in their structure. And this is not a problem easily fixed. The authors of this study go on to explain that the root problem is the abundance of evaluations that are not aligned. Suppose Model A is an aligned model that correctly signals uncertainty and never hallucinates. Let Model B be similar to Model A, except that it never indicates uncertainty and always guesses when unsure. Model B will outperform Model A under binary scoring, the basis of most current benchmarks. And this creates an epidemic of penalizing uncertainty and abstention. So the whole idea, or the idea, is that the whole ecosystem of LLM evaluation is the problem. It cannot be fixed piece by piece, but would have to be overhauled in its entirety because hallucination simply performs better on binary metrics. It seems that contingency arises in LLMs not only at the technical level of their architecture, but in the socio-technical practices which measure and legitimize their performance. In closing, I will certainly not try to predict the future. I hope merely to have pointed out that the political economy of prompting must attend to questions of determinism and contingency, and that these have both a technical and a social dimension. Thank you.
感谢詹姆斯·斯坦霍夫老师的精彩分享。现在我们进行问答环节。如果有观众想要提问，请举手示意。工作人员会将麦克风递给您，谢谢。
Thank you for your great talk, James. I like your idea of that prompting is labor. I think it's a very persuasive argument. So as you mentioned, there are different groups of people involved in the labor process. There are data scientists, there are data workers doing the labeling. So my question is about their internal dynamics. Like, if the result is unpredictable, right? If we want to improve the quality of the model or data or result, is it possible to introduce any auditing practice or auditing system? And if it's possible, you know, which step is more feasible to do this auditing, you know, to improve the quality of the output? I'm not sure if you get my question.
Well, I think that's what the last study is trying to get at, is that, like, even before auditing the performance, the benchmarking, like the process is optimizing for hallucinating. Like it's actively forcing the models to hallucinate. So as I interpret that study, auditing would be like, you know, putting the bandage after you get your arm ripped off, right? Like trying to patch the problem after the fact, but the auditing wouldn't be able to correct this, because that's literally what they're teaching the systems to choose, like to prefer. So I think if I understand their argument, that auditing, you know, can't fix the problem. It can't get rid of hallucinations. It might be able to increase performance, you know, by bracketing out some undesirable kinds of performance, you know, by putting in certain guardrails or something, I guess. But the hallucination problem seems to be contingent on the fact that it works better, typically, and so. Well, yeah, I guess their argument is that because you'd have to change, everyone would have to agree to switch the metrics. Because anyone who does switch the metrics to optimize away from hallucinating will probably make the model perform worse. So then nobody will want to use it. So then why would anyone do that?
So thank you, James. I'm with Felix from yesterday. I think that models hallucinate 100% of the time, and there's no way out of that because they're only using internal information as if we had what was in our minds, but no perception. I wanted to ask, I thought it was intriguing that you look technically at these issues of determinism and non-determinism. So there's several layers here. So, I mean, first of all, lossy compression doesn't mean compressing an image or uncompressing an image, like a JPEG image, doesn't have to be non-deterministic. If you open up a JPEG image on your computer and display it full screen, you do that a dozen times and you take a screenshot. It'll be pixel by pixel identical. So there's no non-determinism because of lossy compression, for instance. And I could say more, but
okay.
But I don't think the question of determinism or non-determinism is really the issue at all, because as Felix pointed out, if you have, for instance, financial simulations, they may be non-deterministic, but you simply set a threshold at which you're willing to assume something is true. So over 80% of the time, this means you should sell your stock that you have holdings in. And similarly for like a weather simulation, right? So, which could be how you report things, you know, on the news, or it could be whether you choose to take an umbrella with you, right? So we have plenty of ways of understanding non-deterministic types of simulations that are computational simulations. I think the problem, and this is what I thought was funny, because you come at this from the standpoint of political economy, but the problem is that we have opaque, corporate, proprietary models that everyone is using, and then so we don't know, for instance, with ChatGPT 5, even how many parameters the LLM it is based on has. We don't know what it's trained on. And also, it's constantly in flux. It's changing all the time. So if we're trying to do a scientific experiment using that, right, we don't, the model that we have today is not the model we have next week. Yeah. So it's okay if we have a weather simulation that's non-deterministic, we could still use that model as long as we are using the same model, right? So it's not about non-determinism or probability, it's about the fact that the corporate actors who control these models are keeping them isolated, opaque. Anyway, so that's more of a long comment than a question, but I wanted to put that out there because I think it brings these questions much more into your wheelhouse and your area of critique here, and I'm wondering what your perspectives from political economy have to do with that type of angle.
Well, I totally agree with you about the intentionally keeping things in the dark. That's an aspect, yeah, like definitely, totally agree. But I do think that the non-determinism of these models is troubling for people trying to sell LLM commodities, because especially with the whole agentic AI, where you're going to theoretically delegate all sorts of business processes to this agent, if someone's going to buy your agent and say, okay, take charge of the company credit card, you know, go forth, or plan our logistics operation and I don't know, send emails, like presumably if you're going to buy one of these commodities, and I hate using the word trust about AI because I think you shouldn't trust it, but if you wanted to sell someone of these things, they'd have to trust it, and right now all they can offer to customers is like, trust us. Don't worry, it probably works. And sometimes it won't, though, because we know that it won't, and we won't be able to explain to you what went wrong either, because it will just be like a mystery.
Yeah, I think it's very insightful to think about giving the credit card to a system to work on logistics, for instance. But in fintech, those machines have credit cards with very, very high credit limits.
That's true.
And they buy and sell, you know, based on completely probabilistic
yeah, that's true.
Determinations.
True. Yeah, there's something different there to be said about different areas of application, I guess. Mm.
还有要提问的吗 ？OK。
maybe sort of also a follow-up on the question too. I'm wondering, going back to the labor problem that you were mentioning, do you see any more good in the hallucination and the prompting, the prompt labor, prompt engineering that laborers are gonna adopt more and more? Because I'm thinking that if there are more laborers who will be doing these jobs, doing prompts, and then even have their prompts sold on the market, and the prompt engineers probably are also the ones who have to deal with hallucination and the non-determinism every day. So for these laborers, from the type of the studies that you do, to have any insight or I don't know, like, are there ways that they could be freed from this type of job, even if, I guess, speculatively or in a theoretical sense?
Can you reformulate like, just give me a short version of the question? I'm a little spaced out from the talk and I lost the thread.
Oh yeah, sorry. Maybe simply just wondering, the prompt engineers who will be the laborers working with the prompts, working with the problems of hallucination and non-determinism, they'll be, like you also addressed, they'll be stuck in not just this type of the work, but this effect of these hallucination and all these problems. So in the type of the studies that you do you have, I guess, do you see if these laborers will have more freedom in kind of seeking if they cannot get out of this type of job in the long run? I don't know, does it make sense?
Well, I haven't done research on people actually using generative AI myself, so I don't have any like direct empirical insights on that. My empirical research on work relating to AI has been people who make the AI systems, not people really using them. So I don't have any direct insights, but I think one thing worth noting is, like Felix was saying, in a sense, all output of generative AI is a hallucination. I would say that the hallucination is relative to what you want it to do also, right? If you want it to generate images about a speculative topic, then that's fine. Hallucination is not really a thing. Hallucination is only when you tell it, retrieve a certain fact, and it says, okay, I have, and it lies to you. Like that's the concerning part, right? I think that's the one that the businesses and such and scientists are concerned about, because that means you can't use it. You can't use generative AI to produce. I hesitate to say truth, or like, it's not retrieving information in the same way. It's not a very good answer. I don't know, let's talk about it after.
Okay.
This might not be a very satisfying question either, but ultimately, does capital care about quality?
No. But it cares about selling commodities, and to a certain degree, a commodity has to reach a certain acceptable level of commodity or people won't find utility in it and won't buy it. So the lowest level of quality that is acceptable to the consumer is what it cares about.
It just strikes me that we're like building machines to correct the machines. Every layer of machine is adding, I don't know, 62% more work. And it's like all of a sudden, especially when you're dealing with like fintech or whatever, maybe this is me, the scale is so big that like adding 62% for every prompt or whatever just might make it like at a certain point, you might as well just use an algorithm rather than like a large language model. So,
well, yeah, and I think, I mean, if I had to predict one outcome of this, is that there's going to be a filtering of what applications are actually viable for generative AI. Like a lot of the proposed applications are just silly and not going to work because of the inherent like hallucination aspect of these systems, right? Like, why wouldn't you just use a search algorithm to find stuff for half the problems that maybe more, right? So, yeah, like some of this silliness is just going to get nuked out whenever the bubble pops, presumably.
还有想要提问的吗？还有观众想要提问的吗？好，谢谢詹姆斯·斯坦霍夫老师，谢谢您的分享 ，Thanks。
Thank you。
接下来是今天最后一位发言嘉宾陆苗老师。陆苗老师是香港岭南大学文化研究系的助理教授，他的研究兴趣包括基础设施研究与中非研究。他的演讲主题是热带地区的数据中心、西非的热量管理、中国科技与能源政治。有请。
So good morning, everyone. Thank you so much for having me. I have been a big fan of this conference for years, but it's my first time to attend it in person. So I really appreciate. So my name is Michelle Miaolu. I also have an African name called Ajua, meaning born on a Monday. So I'm from the Department of Cultural Studies at Lingnan University in Hong Kong. The research I want to share today is a collaborative project with Dr. Sarah Mavli from University of Massachusetts Amherst. Unfortunately, Sarah cannot join us due to teaching obligations. So the title of our presentation is Data Center for the Tropics. Heat Management, Chinese Tech, and Energy Politics in West Africa. It's still work in progress. We just finished part of the fieldwork this summer, so today I will share some thoughts and preliminary findings. Before I start, let me briefly introduce my background to give you a better sense of my scholarship. So starting from 2016, I have been researching the rise of Chinese technology in the global south. My first project, which is also my PhD project, looks at Chinese mobile phone in Africa. I studied a Shenzhen-based company called Chuanyin, which is currently the largest mobile phone seller in Africa. I finished this project, and my book will come out this December with the University of Illinois Prize. After joining Lingnan, I started 2 new projects, both about infrastructure. One is about China-built base stations in Africa. As you may know, base station is a kind of last-mile infrastructure that connects our phone to the internet through a side tower. So specifically, I'm looking at a lightweight base station project from Huawei called Eurostar, which can provide 3G and 4G services to rural areas in the developing world. So the picture in the middle shows a few Huawei engineers deploying a Eurostar base station to bring the internet to this small village in Ghana. So if the village is not electrified, the base station can be powered by a few solar panels. So it's much more affordable and flexible compared to traditional cell towers. Another project I've been doing right now is what I call tropical data center, because I want to study China-built data centers in the tropics. So these are 2 data centers I visited, one located in Jakarta, Indonesia, and the other in Accra, Ghana, which is also I'm going to talk about today. So the demand for data center is not new, but it's being accelerated by the global race for AI and cloud computing, as exemplified by the high-profile Stargate project led by OpenAI. As other speakers mentioned yesterday, a data center is important because it's where AI is being materialized. And according to the industry prediction, global demand for data center could more than triple by 2030, depending on how quickly and widely we will be using AI. And far from being a neutral infrastructure, data center often invokes certain socio-technical imaginaries in many countries. So in Iceland, state and industry leaders mobilize the images of wildness and greenness to attract foreign investment in data center industry. And in the US, especially the Rust Belt, constructing data centers for Silicon Valley tech giants brings the anticipation of economic growth and imaginations of technological modernity. And in Guizhou, southwest China, data centers are linked with provincial big data dreams, and meanwhile, the larger project of state building as China aims to enhance its cyber tower in the global cloud race. So in practice, however, many of these promises are contested, and challenging the tecto-utopian green narratives around AI and cloud. Many scholars have reviewed the environmental politics of data centers, like the enormous consumption of water and electricity, the generation of heat, waste, and carbon pollution. And tensions have been documented in many communities where data center operation depleted our local resources like water and electricity. And facing a variety of environmental challenges, many data centers are strategically positioned in temperate zones like Nordic countries to utilize the cold air for reducing the temperature, a technique known as free cooling or natural cooling. So if we look at the current geographical distribution of data centers, a majority of them concentrate in temperate zones. As you can see from this map, North America and Northern Europe have the 2 biggest clusters, which is not surprising given that North America hosts a lot of big tech companies. And while Northern Europe has cold air, renewable energy, and favorable tax policies, all of which can be very attractive for data center investors if they want to reduce the energy cost and carbon footprint. By contrast, only a small number of data centers are located in the tropics. I added a tropical belt to this map, which might not be very accurate, but still we can clearly see the difference, right? Well, things have been changing recently with the rise of Chinese cloud providers. So as the domestic market gets more and more crowded, Chinese tech companies are going overseas to look for new opportunities, with many making forays into the tropics. Huawei, for example, has been building data centers across the African continent. Previously, Huawei had played a critical role in building Africa's 3G and 4G networks. Data center is a relatively recent business in response to the rapid digitalization in the continent. And in 2021, when Senegal opened a national data center built by Huawei to enhance its digital sovereignty, it triggered concerns over the dependence on Chinese tech. And in Southeast Asia, Chinese companies like Tencent, Alibaba, and also the Shanghai-based GDS, 万国数据, are investing heavily in Singapore, Malaysia, and Indonesia. And departing from the temperate normality, China's expansion into the tropics suggests both the geography and materiality of cloud infrastructure in flux. And this raises a lot of questions about the business logics and infrastructure practice of Chinese tech companies. For example, the hot and humid tropical climate is often deemed as disadvantageous for data center operation. So since servers will break down in conditions that are either too hot or too cold, thermal control has been essential for data centers to keep the temperature within certain range. That's why sophisticated cooling systems are often required to maintain the optimal temperature inside a data center. So in this sense, the work of computation is also the work of managing heat. And data center can be seen as a type of thermal infrastructure. That's why a great number of scholars are attending to the thermal cultures of media infrastructure, including me. So in her inspiring essay, Thermal Cultures of Geological Media, Nicole Starosiewski argues that thermal manipulation is critical to the transformation of the Earth's raw material, such as copper and silicon, into media, and to maintaining those materials as media. And one interesting thing she mentioned that when the first air conditioner was invented in 1901, it was not intended to cool humans, but rather to standardize the temperature of color printing, because fluctuating temperatures will make the inks overload imperfectly in color printing. So the question we want to ask in this question is how heat is managed in running a tropical data center, and how do Chinese tech companies navigate the heat problem in the tropics, especially given the recent green turn in the data center industry. So specifically, we use tropical materiality as a theoretical framework to explore the thermal practice of tropical data center. On the one hand, this framework draws from media studies, infrastructure studies, and STS, science and technology studies, that increasingly explores the environmental politics of data infrastructures. On the other hand, we want to intervene in current scholarship that predominantly comes from European temperate contexts and is informed by Western philosophies and theories. Put it another way, we want to tropicalize data center studies. So we define tropical materiality as how tropicality intersects with materiality in making artifacts, including infrastructures. So the materiality here is easy to understand, which refers to the quality and character of material matters that are used to make artifacts. So the tropicality here refers to an assemblage of climatic, geographic, and imagined traits about tropical lands and people, which often mixes natural differences with cultural interpretations. Therefore, tropicality is not neutral, but embeds positive or negative meanings. And this is because the tropics are both a geographical zone and an imaginative construct. So geographically speaking, the tropics are regions of Earth surrounding the equator, located between the latitude lines of the tropical Cancer and the Tropic of Capricorn, 南北回归线之间 So unlike the clear boundaries between continents and seas, climatic zones are created by the longitudinal distinctions on the planetary level. They are invented as both a place and an epistemology. So in European imaginations, the tropics often appear as a duality. On the one hand, the tropics are imagined as an earthly paradise with beautiful nature, abundant resources. On the other hand, the tropics are seen as a dangerous place with tropical disease, uncivilized people, and culture. So when Europeans defined foreign lands as the tropics against the metropole, they also ranked the climates, with the temperate zone indicating the mild, suitable, and well-disposed, while the tropics indicating the dangerous, inferior, and uncomfortable. And since the colonial era, infrastructure has been a critical element of European engagement with the tropics. So through building infrastructures of mining, ports, railways, and plantations, the colonial states and the royally chartered companies opened the tropics to the global trade, including the slave trade. And facing unfamiliar environments, the imperative to study, to control, and modify the tropics gave rise to modern disciplines of botany, architecture, and medicine. When architects construct tropical architecture to cope with the heat, doctors tackled the threat of tropical disease by producing new tropical knowledge and deploying new medical infrastructures. So to some extent, the successful colonization of tropical lands is a matter of knowledge and of the application of knowledge. So if we define tropical knowledge as a way of knowing what the tropics are and how to use them or live with them, the hegemonic knowing subjects have been Europeans, whose knowledge structure facilitates the accumulation of modern capitalism in the tropical world, and meanwhile reconfigured the tropical materiality. So, for example, in this interesting book called Cooling the Tropics, the author Haley Julia Hobart looks into the history of ice and coldness in Hawaii. So to facilitate the tropical acclimatization of white occupants, ice was employed as infrastructures of cold to calibrate the thermal environment in Hawaii, which also contributed to new leisure cultures and lifestyles. So the other two pictures were taken by me when I visited the Dakar railway station in Senegal, West Africa this June, which is a typical example of tropical architecture, I guess. I didn't see any air conditioner used, but it felt pretty cool when I was moving around in the station. And the history of this railway station can be traced to 1884 during the colonial era. As the first railway line built in French West Africa, it played a crucial role for the global transport of raw materials from this region. And some people even say the city of Dakar have grown around this transport hub. So here, heat management not only aims to make people's mobility comfortable, but also to facilitate the extraction of raw materials for the global trade. In either case, heat is not a depoliticized phenomenon, but socially, politically, and culturally produced and managed. Well, despite its hegemony, the West is not the only knowledge producer about the tropics. What the tropics are is not static either. So in different historical periods, the term tropics refers to overlapping geographic areas with the colonies, the third world, the global south, and more recently, the emerging market. So the dramatic terminology change not only suggests the changing geopolitical and geoeconomic positions of the tropics, but also the changing knowledge power complex. So in the mid-20th century, for example, the tropics evolved into the center of a global revolution when oppressed countries self-identify as the third world and fought for independence. In particular, guerrilla wars appropriated tropical knowledge by transforming the jungle into a means of camouflage while utilizing the heat as a source of warmth. And if you look at the propaganda posters designed in the Maoist era, one popular theme is black guerrilla fighters reading Mao's Little Red Book. So in these Chinese imaginations, the tropics became a space of revolution that is progressive, dramatic, and justice-oriented. And it's also in this period that China started its large-scale infrastructure engagement with the tropics. And to assist the newly independent nations, China funded a large number of infrastructure aid projects in the African continent. And China often highlighted their anti-colonial and anti-imperialist nature. And one notable example is the Tanzania Railway, 坦赞铁路, financed by China in the 1970s. And so by linking Tanzania with Zambia's copper belt, Tanzania Railway reduced their dependence on colonial railway. And hailed as the Freedom Railway, Tanzania is widely articulated as a symbol of Asia-African solidarity. Well, in practice, however, Chinese aid project encountered numerous challenges, which also pushed China to explore alternative approaches. So in Africa, the lack of capital led the Chinese to use a labor-intensive approach of the poor helping the poor to build Tanzania, which involved intensive cooperation between the two sides. Another big challenge faced by Chinese engineers is the lack of local knowledge and statistics. So in Liu Ye's study about Chinese aid project in the Maoist era, he interviewed a Chinese engineer who had worked in Sri Lanka. He revealed that when the Chinese team arrived in Sri Lanka for an aid project, the technical data provided by local government included snowfall statistics. And they later realized that this data was generated by and for the British metropole instead of Sri Lanka. And I also encountered a fun example during my trip to Malacca, Malaysia this year. So when the Dutch colonizers arrived in Malacca in the 17th century, they built houses with fireplace in preparation for the cold winter. Without knowing that the winter in the tropics is different from the winter that's in Northern Europe. So I found this picture online where you can still see the chimney on the rooftop of the Dutch colonial houses. So in such context, how to engage with tropicality less mediated by Western knowledge became a new task for Chinese engineers. And to make the infrastructure more tropical responsive, Chinese engineers had to unlearn Western knowledge on the one hand, while relearning the tropics from the Chinese perspective on the other hand. And oftentimes, they had to conduct their own surveys. As Liu Ye documented, the construction of a textile factory in Tanzania entailed a systematic learning of local environment by collecting data about sunshine, wind, rain, humidity, mildew, insects, rivers, and soil. So questions thus arise when China taps into the tropics to build digital infrastructure in the 21st century, which requires a lot of new knowledge to make the data center not just functional, but also green. So what are the challenges? How might the tropics be reconfigured and reimagined in the digital era? So to explore these questions, we focused on Ghana National Data Center as a major case study. So located in the capital, Accra, the Ghana National Data Center was built by Huawei in 2016 and financed by a concessional loan from China Exim Bank, 中国进出口银行. So its daily operation was managed by a government agency called NITA, National Information Technology Agency. So the picture here shows the NITA headquarters, which is also where the data center is located. When I visited last year, the data center only occupies 2 floors inside this building. While in response to the growing demand, NITA has been working with Huawei to expand it since last November. And the major research methods we use are ethnographic fieldwork and interviews. So we haven't finished the data analysis yet. So today I will only share some preliminary findings around these 4 questions. First, why does Ghana want to build this data center at the very beginning, and why Huawei? And according to my interviews with NITA officials, the data center project was conceived as early as 2012 when the government realized that the lack of infrastructure had become a major hurdle to Ghana's digitalization efforts, either for public or private sector. So if the government could build this data center, it can lease out the space to people who need it so that they don't need to build their own infrastructure. So the major motivation of building this data center was to stimulate the market at the beginning. So by this year, around 25% of the data center capacity is used by government agencies, and around 75% by private sectors, including some banks and telecom operators. During and after COVID-19, this demand grows even faster as more Ghanaians are using digital technologies and services. So when I talked to a NITA official this summer, he said that the market has taken off, and the future goal of NITA is to transform Ghana into a data center hub in West Africa. Because he thinks Ghana is politically stable, it connects to a few undersea cables, it has stable power supplies compared to other African countries. So for a few times during our conversation, he mentioned the opportunities of digital economy, or AI, and how data center is crucial for taking up those opportunities. And meanwhile, he also envisioned Ghana becoming a popular location of digital embassy if other African countries are willing to store their government data in Ghana. He said in the future, the role of NITA will shift from a data center provider to a regulator to facilitate more data center providers coming to Ghana. Well, whether this can be achieved or not is yet to be seen, but I think this narrative suggests a new type of socio-technical imaginary in Ghana, which not only aims to stimulate the domestic market, but also dreams about becoming a regional hub in West Africa. And then, why Huawei? So according to Solomon, the technical director of NITA, they choose Huawei due to economic considerations. So technically speaking, Huawei was not the best at the time. Cisco and Ericsson and Nokia are much better back to 10 years ago, but Huawei was cheaper, and Huawei came with funding. What he means here is not that Huawei funded this project itself, but that Huawei facilitates the negotiation between NITA and China, which provided a loan to Ghana to fund this project. And interestingly, Solomon says, even if they have their own money right now, they are still willing to work with Huawei because, quote unquote, Huawei has grown so much and its technology is very advanced. So this pattern repeats in my observation of other sectors like 3G, 4G networks, and in some other countries like Senegal. So during its early expansion in Africa, Huawei often benefited from the financial support from Chinese development banks, but this factor becomes less important as the company moves up the value chain by making its technology both affordable and reliable. So to manage the heat generated by the servers, NITA uses a technique called water cooling to cool down its data centers. It's a type of liquid cooling that uses water to lower the server's temperature. So compared to other techniques such as air cooling, liquid cooling is quieter, more efficient, but also costs more because it consumes a lot of water and electricity. So in the NITA case, water is supplied by Ghana Water Company, and power is supplied by ECG, Electricity Company of Ghana. Both are state-owned public utility companies. And one important indicator to measure a data center's power efficiency is the PUE value, short for power usage effectiveness. So PUE was introduced by an NGO called the Green Grid in 2007 and quickly became a global industry standard for measuring the power efficiency of data centers. So the Green Grid is a nonprofit open industry organization headquartered in Oregon, the US, which aims to improve the resource efficiency of data centers. It has 175 members, including Dell, HP, IBM, Oracle, and Microsoft. So mathematically speaking, the calculation of PUE uses a very simple formula. You just need to divide the total facility power, that is, total energy consumption in the data center, by the IT equipment power, that is, energy used by the IT equipment. So a lower PUE means higher efficiency with an ideal score of 1.0. So 1 means that all power is used for IT equipment and none for cooling. A higher PUE indicates that significant energy is wasted on cooling and other supporting systems. And according to my interviews with NITA engineers, the PUE of Ghana National Data Center ranges from 1.5 to 1.9, which is not very efficient compared to other countries. In 2021, the Chinese government set standards of 1.3 PUE for data centers in temperate regions and 1.25 for colder regions, which is a very strict standard. And after this standard took effect, many Chinese data center providers shifted from air cooling to liquid cooling because traditional air cooling can never meet this efficiency requirement. Well, in the tropical world, Singapore is one of the few that have set up a PUE standard, which is also 1.3 and also very strict. Another data center I visited in Ghana has a PUE of 2.2, even higher than this one. So this means that data centers in Ghana have to waste more energy to cool down its data centers, which is understandable given its hot climate. Although Ghana hasn't set up any PUE standards for its data centers, institutions like NITA are motivated to lower the PUE because higher PUE value means higher electricity bills. So to make sure that power is always on, NITA adopts the 2N+1 architecture for its data center. which means it has two independent power systems, that is, two different grades, plus an extra diesel generator for emergency use, for example, during blackouts. Unlike big cities such as Shanghai, blackout is still very common in many African cities. And in Ghana, people coined this term called doomsol to describe the frequent blackout during previous energy crises, meaning off and on. So the picture on the left is the diesel generator as backup power for NITA data center, because data center does not like blackouts. So regarding Ghana's national grids, it currently relies on thermal power plants that generate electricity from fossil fuels like oil and natural gas, and hydropower plants that generate electricity from moving water. And while hydropower used to be the primary power source in Ghana, but as the water level becomes lower due to climate change, Ghana increasingly shifted to thermal power stations, which now accounted for 2/3 of its electricity production. So back to the NITA data center, although my interviewees didn't disclose the details, this data center consumes a lot of power. There was a time when the electricity bill was so high that NITA cannot afford it. So ECG, Electricity Company of Ghana, threatened to cut off the grid if NITA didn't pay the bill. So to diversify its energy source and reduce the cost, NITA introduced solar energy in November 2024 by transforming its parking lot into a mini solar farm. So when I visited a few months ago, I saw birds standing on the solar panels, which beautifully captures the entanglement between nature and data infrastructure. So there are two major motivations behind the use of solar energy. First is to reduce its dependence on grid power and thus ECG. Second is that NITA wants to set an example for other data center operators that they can reduce the environmental footprint by using more green energy. So at the national level, Ghana pledges to achieve net zero carbon emission by 2060 and sets a target of having 10% renewable energy in its electricity mix by 2030 as a commitment to the Paris Agreement. So the percentage of renewable energy is only 1 in Ghana by 2025. So solar energy will be a critical element of this green transition. And with the investment from the World Bank, or Europe, and increasingly China, Ghana has introduced a number of solar projects over the past decade. And viewing the sun as an opportunity, investors and policymakers often depicts how African countries can leapfrog to a green energy future by taking advantage of the tropical climate while avoiding carbon-intensive fuels like oil, coal, and natural gas. So here, the heat from the sun is seen as a resource instead of a challenge. In reality, however, Ghana's energy transition does not happen along a linear, singular pathway, but full of erratic, contradictory logics. The first challenge is that solar energy is not necessarily cheaper. In Ghana, solar energy is often more expensive than other sources of knowledge, especially in the first few years. And one major reason is ECG signed too many take-or-pay contracts in the early days. So take-or-pay contracts is a commonly used contract in the energy industry where a buyer either buys electricity from a producer or pay a penalty for electricity it does not use. So the picture here shows a huge solar farm I visited in a small town called Winneba, 2 hours from the capital, Accra. So it's one of the largest solar power stations in West Africa. It's built by a Chinese company called Minage, and the boss is a businessman from Guangdong province. So when Ghana promoted a solar project in 2016, many companies were interested, but only Minage, this company, was able to secure enough capital to build it. And the first phase cost him around $20 million. So Minage signed a 25-year take-or-pay contract with ECG with an electricity price of 20 cents per kWh, which is around 1.42 RMB per kWh, 大概1度电1块4毛钱. And this is very high if you compare it with Shanghai, which is at 0.6 RMB per kWh. And when I interviewed ECG this summer, they told me they were negotiating with this Chinese company to lower the price. Well, in principle, you cannot change the price once you have signed this take-or-pay contract. But the price was so high that ECG cannot afford it anymore. And another big challenge of solar energy is maintenance. So maintaining solar infrastructure in the tropics can be difficult due to the shifting tropical materiality. For example, solar energy can be very unstable due to the changing tropical climate. Like during the rainy season from May to September, solar panels often have difficulty in converting sunlight into electricity. If the battery gets short-circuited during lightning strikes, the whole panel will break down. And the dry season also has its problem due to the occurrence of Hamadan, a dusty season between November and March that will bring a lot of dust. And too much dust will also affect solar panels in capturing sunlight. And when I talked to local workers in the solar farm, they told me that their job also included weeding and cleaning the bird droppings, because they can also affect solar panels in negative ways. I put the picture here to give you a sense of how wild the grass is. If it's too tall, it will block the sun. So in this sense, I think the industry narrative is quite misleading by depicting solar energy as a clean, easy, and affordable energy solution, which significantly mystifies the solar technology by obscuring its everyday materiality. And unstable materiality is not something data centers would like. So to summarize, there exist at least 2 layers of thermal manipulation in the case of the NITA data center. In terms of electricity generation, it's a process of transforming natural or chemical elements, such as the sun, fossil fuels, into heat, and then electricity. In terms of cooling system, it's a process of using water and electricity to reduce or eliminate the heat generated by computer servers. And both processes assemble social, political, and natural forces that may stabilize or destabilize the data center operation. So in such context, thermal manipulation of data centers are not just technical activities, but also socio-cultural practice that involve normative assumptions about what kind of material transformation can or should take place in a society. If heat management for a green data center entails a series of requirements regarding its carbon emission, power efficiency, and use of renewable energy, we need to ask who has the power to make these decisions, how and why, and with what impact. In particular, we call for cultural studies of heat to reconceptualize thermal practice that are socio-cultural and socio-technical. And last, instead of treating nature as a neutral background, we should add it as an important actor which interacts with state and capital in shaping the materiality of data centers. So at the operational level, we approach tropical materiality by analyzing how state and capital mobilize various elements to power, cool down, or maintain data centers. While we reject climate determinism that considers climate as the only decisive factor, we acknowledge the agency of elements in data center development. They can be reconfigured by various types of state and capital, and they may resist or push back against the imposed control. So overall, we hope to elicit new inquiries about the materiality of data infrastructure from a tropical perspective. So last, I want to ask a provocative question that what if Shanghai becomes a tropical city in the next century because of global warming? You know, the tropical zone is not fixed, but may bridge its existing lines if the Earth gets warmer and warmer in the future. And if Shanghai becomes a tropical city, current tropical cities like Accra or Malacca will become super hot places that we have never seen, right? I hope humanity will still exist in that world, and I hope that will not happen. So I will stop here. Thank you. I look forward to your comments.
Thank 谢谢陆淼老师的分享。下面进行问答环节，如果有观众想要提问，请举手示意。
Yeah, thank you for the talk and the provocative idea of tropical materiality, the construction of the tropics as a colonial, European concept, which is, of course, goes on top of all of the African nations, which are constructed also by colonialism, the modern day countries that are there, just like in Central and South America, those borders are drawn by colonial forces. But this is another layer on top of this, that all of what the tropics is and what we imagine it to be is this way. I was interested, though, in the contrast between Dylan's film and the way that people in Catalonia, in Brazil, other places, are coming up with decentralized, not just concepts, but decentralized approaches, decentralized technologies for internet access. And even though this approach is very sensitive to temperature, humidity, weather, it's still sort of taking the industrial or post-industrial data center and then putting it into the tropical context. So I'm wondering if there's any thinking beyond the data center, which is the centralized idea. Is there a decentralized idea that is an answer to the data center?
Do you mean, can we build build the internet without data center?
Yes.
Oh, I don't think that's impossible. Because you need to transfer a lot of data, right? For the internet, basically it's about data moving around the world. And you have to store the data somewhere. So that's why data center is where the internet is materialized, where AI is being materialized. So thanks for your question. I think I left early last night to prepare this talk, so I may missed some part of Dylan's film. But I know the Brazil case. I think is fascinating. Actually, another project of mine is about the base station, right? And in Brazil, people are also building their own community internet using local resources like local trees, a wooden pole, So there are also cases that people can build their own community internet, like the one Dylan's film showed yesterday. But I think it's decentralized. But my question is, can it scale up, right? And if it cannot scale up, you know, that's a question. Like, if you want to connect more people, right? Because because the internet is basically a network, and the scale is a very important factor here. So maybe one thing we can think about is how to connect those local community internet with the mainstream internet. Yeah, that's a good question. Yeah.
Yeah, I was thinking of, I mean, there are peer-to-peer networks on the internet, like Napster earlier and BitTorrent, you know, more recently. And so they don't actually require that there be a centralization of data resource. If we're talking about data itself and not GPUs running, then the data itself doesn't all have to be stored in one place. Just like our libraries, we don't have to have one library per country, you know, or like a very small number. They can be distributed throughout the area, and people can access those libraries in different ways. So I would just think, yes, you are definitely correct that data centers are how the internet is materialized right now, but we could always imagine, we could think beyond that.
Okay, thanks for pointing this out. Yes, I think our imagination is limited to some extent, enclosed by the industry narrative, right? I think we need to open up the imagination, and I'd like to know more about the case you mentioned. Thank you.
Thank you. Thank you, Professor. I like your idea of tropical materiality, and my question lies in the other side. Infrastructure studies show that infrastructures in the global south are often like fragmented and expedient, broken, or temporal. But I wonder if that same phenomenon also happened in your case, because data centers are somehow more centralized. They need more resources to build. So I wonder if this kind of a fragmentation also happens in the construction of data centers, like in Africa or in Southeast Asia. And another question is, I also wonder which local actors or communities participate in the construction of data centers, and how these Chinese tech companies like Huawei interact with the local actors. Thank you. So that's two questions.
Okay. Both are very interesting questions. First is about the fragmentation. I think yes, because in the Ghanaian case I'm looking at, they have a few clusters. One is in Accra, the capital, and the other in second largest city, Kumasi. And these are basically two largest clusters, and to cover the whole region, right? But they want to build more data centers, but it's very costly, and there's no plan for now yet. And I think the fragmentation, in my case, is more about the maintenance. You know, because the maintenance is very challenging. And if you look at the solar panels, you don't know where the electricity comes from, right? If you are supplying power to this data center, but the electricity may come from different power plants, solar farms. That's one thing I think related to the fragmentation. But it's very difficult to trace where the power comes from, the electricity comes from. So the second question is about the local actors, local companies. I don't have sufficient information about it right now, but I heard that the building was constructed by a local company because it's a requirement for the contract because they want to create local jobs. It happens often for those state project funded by Chinese loans, and oftentimes African states insist using local company because they want to create more jobs. So basically Huawei is providing equipment. So, and I think Huawei, the biggest thing Huawei is interested in is selling equipment. I think Huawei and its expertise is not on the construction side, right? Yeah. But I will observe more in terms of their interactions, maybe in my next trip. Thanks for your question.
陆博士你好，就是非常感谢你的分享。然后我这边也有一个问题是，也是一直很困扰我自己。方式攫取当地人的一些知识文化，但是现在中国没有在做这件事情。但是我觉得这一点并不能很让我信服，是因为我觉得我们现在目前正处在一个新殖民主义的框架下面。就是我从你的分享当中，我并没有感觉出华为和一些其他的西方大公司有在做什么不一样的事情，对。所以我还是比较好奇，如果说中国的企业要在非洲做很多事情的话，我觉得还是要和一些更多的和当地的文化所互动，对。但是我不知道这一点进展的怎么样了，因为我也看很多非洲他们当地的人会一直很抱怨大型的公司在他们当地所做的很多破坏。然后我也觉得数据中心这个作为一个非常中心化的东西，它更多的还是一个政府侧的这么一个对接，它并没有太下沉到当地的文化和社群当中去，所以这也是一个非常困扰我的问题。对，包括他们也会说像债务陷阱这些都是听了很多的词语了，所以我也是很困惑这一点。就是对于中国来说，我们真的可以做到一个非殖民视角下的，又帮助他们当地发展经济的这么一个行为吗？对。
那这个问题我就用中文来回答好了。这是一个很重要的问题，也是一个很难的问题。首先呢，我会讲一些20世纪的历史毛时期的历史，还有殖民地时期的历史。我觉得回顾历史是很重要的，是因为所有的这些事情都不是decontextualized， 我们需要去回溯历史，然后去 historicize 这一个过程是怎么发生的。但我并不是说我们非得要用以前的那些框架，不论是西方的殖民主义，或者是中国的毛时期的win 或者是 anti-colonial 那些来 frame 现在的这个，我们需要回顾历史的同时要跳出这些框架， 然后你问，那中国现在做的是跟新殖民主义是新殖民主义吗？它到底是什么 ？What's the nature of Chinese capitalist investment in Africa？ 这些就是我觉得是需要一些 empirical study 实实在在的研究去探索的，不是说你要给它一个 label， 它是就是 yes or no， 它是或不是，它可能是非常复杂的，然后是非常是矛盾的，然后不同的 industry 是不一样的。你比如说最近这一年我在做的，比如说手机，或是它那个基站。还有现在的数据中心，或者是你看之前其他的铁路啊、大坝呀这些，它其实是每个 industry 都有自己不同的 dynamic， 对吧？有些 industry 我觉得可能是非常贴近，跟 Western capital 没有什么太大的区别，但是有一些 industry 可能会有一些不同的 dynamic 出来，所以我没有一个。one size fits all 那个 answer 给你，就是因为它是 industry different，industry 是不一样的，然后可能不同国家也不一样，因为不同国家它的 negotiation 那个 power 是不一样的，所以它如何去发展，我觉得是需要一些 empirical research 是去看的，可能是industry by industry, country by country, and case by case, and 可能。等我们的那个观察已经足够深入、足够全面之后，我们可以有一个 conclusion。然后这个是什么？这个 the nature of Chinese capital 是什么？对，我觉得可能现在已经有非常多的中国的学者已经在走出去回答这个问题了。不知道你是不是也是其中一个 ？Thank you。
还有观众有问题吗？
陆苗老师您好，就是我自己本身是长期关注那个中国的数据中心的发展，特别是贵州贵安新区那一边。然后在黄老师就是开幕时候也提到了中国有东数西算这样一个政策。那可能像是我们都知道，我们计算的部分其实大部分是放在东部的沿海地区。那像在贵安，他们其实做的更多的是一个冷数据的一个储存。然后哪怕像今年，就是华为要在贵安说是要建成一个他们人工智能的一个算力中心，但是实际上就是贵州的情况，可能更多他们算力的那个部分体现在他们在做那个渲染农场，也就是影视渲染这个方向。那我想问一下您就是您对于非洲数据中心的研究当中，他们可能就是这些数据中心，他们现在主要的一个储存的类型，或者他们有没有自己的这个算力的部分？以及可能它可能在空间上面可能会不会有不一样的一些功能分布
？OK， 目前我在看的这个 National Data Center， 我觉得是比较传统的，就是你看是10年前建的，然后又是在非洲，我觉得是比较基础的一个 Data Center， 它主要功能也是一个存储。然后像除了政府的数据，还有一些那个银行的呀，还有那个 telecom 那些通信的那些，主要是一个备份来用的。目前我还没有看到，就是中国现在一直在讲 AI data center， 那个。但我觉得，非洲这个我看的 case 还没有这么 advanced。但是东南亚的话，像 Malaysia and Indonesia 那些已经非常多了。然后我觉得是不同类型的市场，就是 dynamic 也会非常不一样。然后东南亚的话，我觉得是变得非常热，最近几年变得非常热，是因为他们那边就可以用到英伟达的芯片。They can use NVIDIA or H100 in Malaysia and Indonesia， 所以就是其实很多连在国内做不了的运算，他们可能会跑到东南亚，马来亚或印尼，然后会去做。但是那边是有很多的 AI data center， but 在非洲的话， 我看的 case 还是比较基础的，并没有太多算力啊、运算啊、AI 的成分在里面。但也许后面会有呢，因为市场发展的这么快。
好，谢谢您。
还有观众想要提问的吗？请举手示意。
Okay, thank you for your talk, Professor Lu. I think it's very important issues in theoretical and practical. I mean, the totality of this word is so kind of challenge to the Western colonial, setup, right? But in practically, I just wonder. I know it's a developing process, but it's also a new geographical expansion on the database world, right? I mean, it's a new space fix and led by China. And I would say that it's because when we say global south, you may know we have another term to replace the global south. It's called global majority, right? Because the south is more than white people countries. I think the populations. So I think if we talk about the Trumpiality, you cannot avoid to answer a new capitalist way on the data center world. I just want to know, of course I totally agree. We need more empirical studies. But I just want to know, how do you see the capitalist way expansion, especially on the global majority and like San Francisco's Silicon Valley? So that's kind of geographical context. I just want to know, what do you think right now?
Okay, thanks for your question. Because this research is still work in progress, so I do not have a solid conclusion about the Chinese capitalist approach. But that's a question I want to explore. I want to answer in my future research. One thing I want to highlight is that capital making is relational. I think we need empirical research to explore how it unfolds in local context, and we can theorize, and then we can theorize on basis of this empirical observation. But I think previous research have observed some differences between Chinese capital and Western capital, like especially regarding Chinese state capital. Right, in Africa, it's less mobile. It's less profit oriented. It's not about profit maximization. It may oftentimes is entangled with other political objectives. And that also makes the capital less mobile compared to international private capital. Well, whether this is a good thing or bad thing for African countries, I don't know. So it really depends how they can negotiate with capital, be it Western capital or Chinese state capital. And I do think in the data center case, I think I'm observing different approaches in West Africa and Southeast Asia, because I want to connect these two regions through the framework of tropical materiality. So in Africa, the commonly used approach is Chinese state capital, Huawei, and African state national data center. But in Southeast Asia, the major player are Chinese private companies like Tencent, Alibaba. So you don't see Chinese state capital. No, from my fieldwork, I think, at least from my fieldwork, I think private capital is the dominant players in Southeast Asia. But I only visited there once, so I don't have detailed observation about the difference. I will let you know if I have the answer in the future. Thank you.
I really want to see the final results when you finish the study, because I think it's very important to China and the global as well. So I really appreciate today's your talk.
Thank you.
还有观众想要提问的吗？请举手示意。谢谢陆淼老师的精彩分享，谢谢您，谢谢观众的提问，谢谢。本届网络社会年会主论坛到此结束，下午1点青年论坛将继续进行，晚上7点半到9点半将进行作品放映讨论会，播放黄孙权作品《旧金山个人计算机与反文化》。感谢各位讲者的精彩分享，感谢各位来宾，谢谢大家，再见。
没关，没关。一组，我给你看一下，大概什么样的。
喂。
别管以后将如何结束，至少我们曾经相聚过。不必费心地彼此约束，更不需要言语的承诺。只要我们曾经拥有过，对你我来讲已经足够。人的一生有许多回忆，只愿你的嘴有个我。
别管你